Hello. Okay, I'm Craig Oda. I'm a partner at Oppkey, and one of the things that we're doing is we're helping a company called Rico. We've been helping them for about 7 years. They contacted us to build up their developer community, and the cameras that we have here, they're 360 cameras, which means they have two image sensors, one on each side, and it'll stitch the image together. So the primary advantage of this type of camera versus a mobile phone is that the pictures can be taken very quickly. So you can take a 360 image in about once every 3 seconds. The cameras can also do 360 video and 360 live streaming to things like YouTube and Facebook. So I'll just go to the presentation. Okay, so we're gonna explain how Flutter can be used for 360 media development, and the image on there is actually a motion JPEG. So the camera will stream over Wi-Fi using HTTP protocol, and it's actually displaying 30 JPEG images per second. So the way motion JPEG works is that it's a stream of bytes, and each of the frames of a JPEG have a start and stop byte. So you have to parse the bytes and display it. And surprisingly enough, the Flutter, just a standard image .byte, it actually will display it with no problems, which is kind of cool. So we have the source code also for this particular demonstration. If you want to improve it, that'd be great, because there wasn't a Flutter package to do motion JPEG for 360 video. So we have a demonstration of it. We hired some high schoolers with very limited experience in Flutter to build 360 mobile applications for us this past summer. Just, kind of a paid internships to help them out too. And they were able to build these type of applications in about 1 day. So if you're interested in Flutter, if you're new to it, or you want to check out 360 images or video, feel free to give it a go. So all of these are completely open source. We have maybe, 30 GitHub repositories of Flutter code for different types of example projects to connect to the camera. The first one on the left is actually a 360 image. So you set up the camera parameters using the Flutter application. The Flutter will talk to with HTTP, send over the request to the Open API, which is based off of Google's open spherical camera specification. So it's always, it'll be used, you can use it across different camera vendors as well too. The one in the center is actually a 360 video. It's using a package. We didn't develop the packages either for the image panorama or for the video viewer. And I'll explain to you how you can do it yourself too. We can also apply the media. So if you don't have a 360 camera, we have a site where you can just download the media for the images and the video and just play around with it yourself, show your friends or create something cool. And surprisingly, the Flutter 360 video actually did work as well too. So the genesis for this is that we were using iOS and Android native SDKs, but they're a bit cumbersome and kind of hard to update. So we just tried Flutter, and surprisingly, it's been working out pretty well. We're using it for prototyping right now. So our job is to help people to understand the API of the camera and bug test it. So we're using Flutter only for the prototyping stage right now, but it's working out pretty good. So if you have a 360 camera and you don't use you could use your mobile phone to stitch together an image, a 360 image, but it's going to take a while. So the primary benefit is you can take an image in 3 seconds, and this camera will take it at 11K. So with a single button press, you could 11K image or 8K video, and you can also stream the video at 4K. And there's different models. Just as a point of reference, I don't sell the camera, so I'm just sharing the information. The consumer model here is about $300. This is the lowest end model. This is the mid-range model here, which is about $800. And there's another one that's about $1,050. So that's kind of the ballpark if you wanted to get into the game with this type of specialized cameras. And you can come around and play with it at any time. So if you just want to take it back to your table right now. You could come out and like play around with it, but you would need an app, right? Because you can't actually see the image on the camera. You have to transfer it over to the app, and I'll explain how to do that. As I mentioned, it can do a stream, and the source code is kind of interesting because if you're not familiar with Motion JPEG, you can actually save the individual frames to your local storage and inspect the frames locally, or take out an individual frame. If you're not familiar with the video, it's just a set of frames, right? So you can save each individual frame and use it as an individual picture. And actually, one of the big uses of this type of camera is to take a 8K or higher video and take it at maybe 2 frames a second, 5 frames per second, and then convert that into still images. So if you're familiar with things like Google Street View or these type of things, this technology has advanced quite a bit. And people are kind of like walking around like this, and they are their own Nuvo or Neuro car. So they're going through a bunch of different places, which I'll explain. If you have any questions, you can also just stop me at any time. Okay. So just to give you a taste of what type of companies are using these type of cameras right now and why they're using it. The Zillow, it's I guess, what do they sell real estate, or they have a site for real estate information, and they have a fairly big, extensive use of the camera to take these virtual tours. So you go in there and a house or an apartment complex, and you take a bunch of these images with their own custom application. Unfortunately, their app is not built using Flutter, because Flutter is kind of new, and by the time we started to promote Flutter, just to test the API, a lot of the companies already had their app in place. So actually, none of these companies are actually using Flutter. I'm just trying to show the example of what the camera is used for on mobile apps right now. We're trying to get them to use Flutter. Maybe you guys can help promote Flutter as well to them. So one use case is apartments or houses to sell it. Another use case is used car. So you probably know that the used car market, the real estate market, has really boomed the last couple of years. Who knows what's going to happen in 2022, 2023, but it was kind of a boom time for used cars this past couple of years. And to take the inside of the car, so almost all the automobile websites within the last 2 years started to put a 360 image of the interior of their car. And they're doing it very rapidly. So the whole thing is the speed. If you can shave off every like 2 seconds off of the time to take a picture, they're willing to pay a fair bit, because they're processing, I don't know, hundreds and hundreds of cars a day at each lot. The one on the right is a local company. And what they're doing, which is super common now, is to take a video of a construction site. You walk around every day, and that's actually a hard hat. So they mount it, they look like a unicorn. I guess I should be more, I don't know if it's a unicorn. Imagine a good-looking unicorn, basically, right, on a construction hat. They walk around, they take the video, and they convert that into still images. And the still images go into the cloud, and it's used for analysis. So you can go back and forth. So the advantage of this type of 360 images is, or video that's converted into image, is that it takes the entire scene. If you take an individual mobile phone, you might miss some of the spots for pipes or stuff like that. And you can take basically the equivalent of maybe 10,000 images, within an hour a day, and do it every single day. The basic process to use Flutter with the 360 media is you first have to sync up the mobile app with the camera. So unlike using the camera that's built into the mobile phone, the camera that you connect to over Wi-Fi has a certain state. So you have to send it a command over Wi-Fi, and then it has to process the command, has to be ready. So the first step in step 1 is to use a mobile phone to capture media, either a still image or a video, and then you verify the media on the mobile device. So imagine if you're taking a picture of a house, right? You go in there, you use a mobile phone running Flutter, ideally, to connect to the camera, and then you get the image back onto the local storage of the the mobile device. And then from there, you attach different types of information like the address of the house, or if you send a car, the VIN number, a bunch of different things. And then you push that to the cloud. So it's a very standard workflow. Once it's in the cloud, it gets pushed over automatically to a website, and then you can go there and you can buy the house. So a lot of these steps actually don't require the use of the camera, right? So steps 2, 3, and 4. So if you want to play around with it, you can basically replicate everything and build the pipeline without having the camera. So we didn't build this panorama package, but if you want to play around with it, you can just go to pub.dev, grab it, and it's super easy to use, right? So it's just an image, right? So in this case, the image is coming in from the network. You just drop in the URL and you're good to go. It's really that easy. The camera actually exposes the media as a HTTP endpoint. So that file URL could theoretically be on the camera itself. The camera has a web server in it. Maybe it's not the best performance because you're constantly going back and forth over HTTP connection to a camera. So what we suggest is you pull it locally to the mobile device, but you could run it directly from the camera if you did want to. And at the bottom, I don't know if we're going to show slides. We have a full example of it as a starter written by a high school student. So we are giving out a camera. It's part of a challenge, not today, but online. If you wanted to, it's kind of a luck of the draw, but let me just explain this challenge just real quickly here. If you want to download the starter code, you don't need the camera, then get the image and just maybe change some options to adjust the zoom of the rotation of it and the navigation, initial view, maybe the rotation speed, and these type of things, and then just upload it back up to your GitHub repository and share the link in our forum. You'll be entered into this lottery to win it's actually this model, which is about $300 or cash equivalent. It's just for fun to try to get people more experience with Flutter and 360 images. Okay. So that's basically the camera that we're giving out as part of the challenge. 4K video and 5.3K images. It's actually the consumer model, but it's pretty good. It's pretty popular. It's widely used for real estate and used car. The 360 video player, which is, this is another code sample that the high school students put together using this package, which they didn't write the package, right? They're just using it. Video 360, so just to show you that the navigation for the 360 video the problem has already been solved. And, because it's using the hardware acceleration, it's a little, maybe you might have to do a little bit of work to get it to work pretty smoothly, but we have it working. The high school kids were able to get it working. Maybe not on your emulator, but if you're having problems, I don't know if you're really push the devices, right? But the emulators aren't super good, especially the GPU hardware acceleration going to the emulator. So if you're having problems, just run it on a physical device like a Pixel, maybe like 4 or something like that. It'll be usually the problems are resolved. So again, the code's pretty straightforward. We're actually pulling this over from Firebase, and we have examples for pulling it over from GitHub and Dropbox, right? So pretty straightforward. You just pull the video file over, and the package will handle that navigation for you. So the main point, if you want to talk to this type of camera and get into the game, is that the entire API calls are using a very simple web-based HTTP type of call. So you're already probably familiar with those. So you're probably already using it, right? The HTTP package, deal, chopper, these type of things. This is what we're using on a daily basis, and you're probably using it too. Like any other API endpoint, the camera is expecting JSON. So you just have to convert the JSON, from the Dart map to the to JSON, and the camera will accept the response and take a picture or video, or you can get a whole bunch of stuff from it. You're probably pretty familiar with this type of thing. So that's the intern was taking a picture at the end of each project. So the camera, of course, is going to send it back to you to your mobile app as JSON, and then you want to convert that back into a Dart map so you can parse out the individual state pieces of the camera. So the camera has, let's say, a battery state, right? Or the camera might be busy stitching the images together. The camera might be busy taking the video and then stitching the two spheres of the video together. So you have to use the API because if you're running it locally on the mobile phone with the camera there, you can just grab it. But because it's on a network, right? You have to send it these commands like all the time in a loop to check to see what the state of the camera is if you really want to take the next action. So because the camera does stitch together two sensor images internal to the camera, it does take a little bit of time. It's not exactly if you use the local camera in your Android phone, for example. And you have to check the status, right? So if you send another command before the camera progress is done stitching it, the API call will fail. So this is pretty common. I think if you're using any type of HTTP API endpoint, you probably have the same challenge, right? So just treat it like an API endpoint and you should be good to go. It's actually a pretty common problem. Like we work with a lot of companies and sometimes even to set the options of the camera, sometimes you gotta wait like maybe 200 milliseconds or 300 milliseconds. If you don't wait, the command could fail. But there's a way to check the status of it too. So you either wait or you tell your app to wait, or you just check the status. Okay. The video recording on this type of camera is actually a little bit more interesting because when you tell it to start the recording the video, it's going to stay in progress, and it's going to stay in progress until not only does the video stop, but the video then is stitched. So the video stitching will take a fair bit longer than an image, right? Because there's more data there. So you really have to pull this thing once every maybe like 200 milliseconds or something until the thing is ready, and then you'll be good to go with the next command. Otherwise, if you chain it together too quickly with this type of device, it will, you'll get kind of inconsistent behavior. Whoa, that wasn't me. I was a little startled. I was like, wow, man, it's like the house is coming down. So if you do this type of development with a hardware device, it could be not just a camera, but any type of hardware device, you do have to sync up the state of your mobile app with the external device, right? So it's the same thing as if it was any other type of camera. And there's a whole bunch of techniques, I guess, to make sure that the camera is synced up with the mobile app, and you know what the camera is doing. So one of the things that the application will have to do is when your app first starts, you want to check to see whether the camera is online, the API endpoint. So if you have it, I guess it's the same on a normal mobile app where if you're trying to get an API call out there, you want to make sure that the camera is connected to the network. It's kind of the same, except that the camera may be turned off. So there's a bunch of different things that you might want to do. A very simple thing is just when the app first builds, you can just send it a command to check the status of the camera. In this case, we're using the block to check the state of the camera. Here's a fun fact. The camera runs a version of Android internally, either maybe Android 7. So we're actually running Flutter apps inside of the camera, displaying on the camera screen. That's kind of a, I don't know how, well, this particular camera, the LCD screen is newer. And so maybe it's going to take off. That could be a kind of an interesting field for people because the camera itself has a touchscreen, obviously. and it can control everything as if it was an Android device with two large lenses on each side. So that's kind of a new frontier. But I did write it in Flutter, and it was pretty cool. Also built games with live animation in the camera, which in the client was kind of like, well, is this really practical? I was like, no, it's obviously it's not practical, but everybody wants to play a game. So this one's using Flame. If you guys aren't familiar with it, it's a game engine, and so Flame has a ride package, so you can play a lot of games on the camera and just don't show the client. Here's the Flutter packages that we use. We didn't write any of these. We simply are just working with the community, and we had a bunch of this past summer, high school kids were helping us out to build some samples. Our primary goal is to test the API, right? So the more ways we have to test the API, the more apps out there. We're not building apps for production use. We're just trying to showcase what the camera can do. I think that might be it. Oh, okay. If you do want to get media samples, like free images or videos, so you can download it, you can drop it into maybe the galleries folder of the mobile phone. We have a bunch of applications, sample applications of open source code that will get you started too. So this challenge here is designed for people that they don't have a camera. And if you complete it, it's going to be pretty easy, right? I mean, it was written by a high school student. So, if you just modify it, you can be entered to win the lottery to get the camera. Yeah, this is actually the challenge, right? So you get the thumbnail from the gallery. We supply the media. It's not from the camera. But if you have a camera, you can take the picture with it. And then we want you to change the orientation of the 360 image. So do you have any questions, or you can run up here and play with the cameras, or you can talk to me later about the cameras, or you might have, it's kind of the same API for the major competitor would be Insta360, GoPro Fusion, these type of things.
Do you capture audio, and do you have any sync and then latency problem or using Flutter?
The latency was with Logger?
Or synchronization problem when you do the video?
So there's different types of video. There's video saved to file, and the video saved to file is 4-channel for spatial audio. So the video is designed to be worn, probably viewed in a headset, like a Oculus headset or something. And so in order to get spatial audio, you need 4 microphones. So different models may have 4 microphones on the body of the camera, or you can sync it up with an external microphone set. And when it's saved to file, then there's no problem with the syncing. If you're trying to stream it over Facebook or YouTube, or we're streaming a single channel audio, I don't think there's a standard to stream like for telepresence, if that's what you're interested in, through YouTube or Facebook. You'd have to set up your own server. And so if your question's about latency, where like like in the movies, you have the VR goggles and the gloves and all that, latency is a problem. It's very common to use it on robotics, and you probably will get motion sickness or VR sickness. So, but I know it's a pretty common use actually to put it on top of robots. Was that your question for latency? No. Okay, yeah. Yeah.
So question about battery life. What's it like on the camera?
So this camera does have a removable battery. Because of the LCD screen and the Wi-Fi and Bluetooth radios in it, it's going to be sucked down realistically pretty quickly, maybe like 1 or 2 hours. So you're going to have to bring multiple batteries to the site. It can run without a battery. It can be powered from USB. So if you put it onto a robot, it can basically run indefinitely without the battery inside the body of the camera. So the other units also too, they can be powered over the USB cable. If you just use it as a standalone device, it won't last very long. It kind of depends what you're doing. Either if it's video, obviously it's going to suck it down faster and still no images, but it's a weak point. It's not as good as a mobile phone by any means. The technology is not as advanced with these type of devices. What do you think I'm doing? You're just curious? Yeah, so you can charge it with a cell phone charger, like a normal cell phone charger, right? So if you go for rental inspection, you can just give them a cell phone charger with it to charge it. It's good enough for maybe 4 houses, most of the units, and then after that you have to swap it. For the drone, plug a USB cable into it and power it from the. I mean, I guess you're sucking down your drone's power source, but that's the most common thing to do. Oh, the drone. Okay, yeah. So that's done too. There's different ways to do it. You could use Flutter and be awesome. You know, that's super awesome. But you can also control it over a USB API. So the camera can be controlled by USB API. You can also live stream over the USB cable. Unfortunately, not with Flutter, but you know, our time will come, and you can then pump that thing into like TensorFlow or OpenCV or something. And it's a pretty common use of it is to use this use case. But the most common way to do it, I'm sorry to say that this isn't usually with Flutter, but it's with NVIDIA Xavier. You know what that is? It's like these single board computers that specialize for AI processing. And then you just plug a USB cable into it, and the NVIDIA Jetson will power the camera, and you can run the stream over that. It's probably a more recommended use, but I have done it with Flutter just because I can. Yeah.
Yeah, like Greg said, feel free to try out his 360-degree cameras. Shall I move it? Okay.